Good day, everyone. Our project is titled Exploring Zoonotic Disease Knowledge Through AI for Enhanced Risk, Prevention, and Response Awareness in Low-Resource Languages. I'm Reolin Govender, and I've worked on this alongside Armand as part of the MIT808 capstone project. Our focus is on improving rabies awareness using AI language tools tailored for Sepedi.
Despite years of public health efforts, rabies remains widely misunderstood, particularly in many South African communities. One of the key issues is that health information often isn't available in languages people understand, like Sepedi. This project asks, can we use large language models or LLMs to bridge that communication gap? We scoped the project around four pillars. First, we assessed how accurately fine-tuned models like GPT-4o and Gemini respond to rabies-related prompts in Sepedi. Second, we looked at inclusivity, how well these tools support underrepresented languages. Third, we evaluated the clarity and relevance of responses from a health communication perspective. And finally, we built a working chatbot to test real-world deployment.
Our approach followed 5 phases: exploratory data analysis, dataset preparation, model fine-tuning, expert evaluation, and visualization and deployment. Each phase helped us build toward a fully functional and context-aware chatbot interface.
We began by analyzing rabies materials from sources like NICD, Google Scholar, and UB Library archives. All of it was in English. We used techniques like word frequency, topic modeling, and named entity recognition to extract key public health themes. The data clearly emphasized prevention, vaccination, and response strategies, especially post-exposure treatment.
We created 60 question answer pairs in English, covering 6 rabies-related themes. These were translated into Sepedi using OpenAI's GPT 4.0, then manually validated by a Sepedi-speaking academic to ensure fluency and cultural alignment. We also built an unseen evaluation set to test how well models generalize beyond the training data.
We fine-tuned two models, OpenAI's GPT-4o and Google's Gemini 1.5 Flash, using our curated Sepedi dataset. Fine-tuning was critical because it allowed the models to internalize rabies content and respond natively in Sepedi without needing translation. This significantly improved fluency and contextual understanding.
We use a structured 5-point rubric to evaluate model responses across fluency, accuracy, relevance, clarity, and cultural fit. A Sepedi linguist rated responses from both fine-tuned models and baseline translation models. Fine-tuned models scored consistently higher, especially the GPT 4.0 model, and showed strong generalization even on unseen prompts.
We built the Streamlit app to bring the models to life. Users can chat with the models, compare the responses, and explore metrics like response time and vocabulary use. It's publicly accessible and designed for use in low bandwidth environments, making it ideal for community health outreach.
This is our Streamlit-based chatbot designed to deliver rabies information in Sepedi using fine-tuned GPT 4.0 and Gemini models. Users can ask questions and receive real-time, culturally relevant responses in Sepedi. The comparison page allows side-by-side model outputs for the same question, helping users evaluate clarity and accuracy. We've also included response metrics and word clouds to visualize models' behavior, such as token usage and key vocabulary trends. Lastly, the use case page outlines how the tool can support public health, outreach, education, and mobile delivery in rural settings. It's lightweight, publicly accessible, and built to make life-saving information more inclusive, right where it's needed. To conclude, fine-tuned LLMs can effectively communicate health information in low-resource languages like Sepedi. However, we face limitations, mainly the small dataset size, limited compute resources, and reliance on a single evaluator. Moving forward, it would be beneficial to expand the dataset, introduce voice support, and deploy the tool in mobile-first environments. The same pipeline can also be extended to other diseases and African languages. Thank you for your attention. We hope this project demonstrates not only the potential of AI in public health, but also the importance of linguistic inclusivity in saving lives and empowering communities. Ke a leboga.